Ladies and gentlemen, here we are looking at example C. This is an example of depreciation. Remember, depreciation will be decay. We are expecting a b value, a factor of exponentiation, to be less than 1. Okay, if you recall from our introduction video, depreciation factors is a decrease in value, so a value starts out at 100% or 1, and we're going to subtract the percentage. But remember, as a decimal, so we're going to subtract 5% from 1. But to subtract 5% from 1, we make it a decimal, so it'll be 1 minus 0.05, which gives us 0.95, which, as we expected, is less than 1. So it is, in fact, a decay function. Now, what this is telling us is that after 1 year, the car will be worth 95% of what it was the previous year. The next year, it'll be worth 95% of that value. So it's continuing to decrease. So we continue looking at the problem. We know that when the car was brand new, or in 2010, the car was worth $32,000. That's our initial condition. That's what we know first. So our A is going to be $32,000. $32,000 in 2010, which will be our time equals 0. That'll be our initial time. So using a variable, so let's go ahead and define that. We're going to let t equal time in years. But it's not just any number of years. We have to remember 2010 represents t equals 0, so it's time in years since 2010. Okay? And we're looking for the value. We're looking for the value of the car in 2013. So we'll let V equal the value of the car. Want to write our function. Our function is going to be v of t, so the value in time, the initial value, or 32,000, times b, so our b value is 0.95 to our variable t. Now remember, we're looking for in 2003. But remember, our t is years since 2010. So our t for this will be the year we want, 2013, minus our initial year, 2010. So our t value will be 3. So we're going to look for v of 3. So we want 32,000 times 0.95 to the third power. Again, we can use our calculator to evaluate that. And we get 27,436. So, don't forget to answer in context. So the car will be worth $27,436 in 2013.